Welcome to Green Numbers Data Tutorials. In this video, I'm going to show you how to use regular expressions to make your code more flexible. In coding, we often need to search for specific strings, and there are functions that help us do this, such as the find function. But what if you're not looking for a specific string value, but a string pattern? For example, rather than a specific phone number, you're looking for any phone number. For this kind of search, we need more powerful tools. This is where regular expressions really shine. With regular expressions, we can search for a pattern, perform fuzzy matching, find and replace a value matching a pattern, and extract a value matching a pattern and save it to a variable. This is the first green number video on regular expressions. This one focuses on matching a pattern. In other videos, I'll focus on finding and replacing patterns and finding a pattern and extracting the value to save to a variable. For this video, we're going to match against this dataset, text vals, with a column named text that includes a sample of text values and sentences. You can see that within these values are phone numbers, social security numbers, and dates. In this example, I'm going to show you the syntax for PRXMATCH, our first regular expression function. PRXMATCH is a find function that looks for our pattern. We're going to use an if statement to look for our pattern, and if we find it, we're going to set the flag variable to yes, indicating we found a match. The syntax for PRXMATCH is as follows. It starts with PRXMATCH, followed by open and close parens. Inside the parens, first you provide your pattern. We'll come back to this. For now, let's just call it pattern as a placeholder. Our pattern is followed by a comma, then the variable we're matching against. Again, we're matching against the variable text. So let's put text in here, and we need to use the strip function so that trailing spaces aren't considered in our pattern. Now our pattern is contained within quotes and forward slashes like this. And inside these slashes is where we create our pattern. Now we could just type the string Steve, and when we run this code, we see that Steve is flagged. But Steve isn't a pattern, it's a specific string value. To create a pattern, we need to use meta characters or wildcards. For example, if we wanted to find a number, we could use the wildcard \d, like this. And when we run this, we see that every string with a number is flagged, and every string without a number is not flagged. So let's comment this out and move down to our next example here. So \D matches any non-digit. And we can see that all values were flagged except for the one that only contained digits. If we put a caret before our digit in our pattern, it tells SAS that our string must begin with the digit. See, only strings that begin with the digit were flagged. If we put a $sign after our digit, then it tells SAS that our string must end with the digit. We see that strings ending with digit were flagged. \s matches any white space character. We see that strings with a white space character or a space were flagged. All strings with no spaces were not flagged. 1 pipe 9 matches either a 1 or a 9. Only strings with a 1 or a 9 are flagged. Values inside brackets tell SAS to match any of the characters inside the bracket. In this case, it's A, B, or C. Strings with an A, B, or C are flagged. In this case, we were looking at lowercase a, b, or c. That's why this 42A with capital A was not flagged. If we put a caret before our characters inside the brackets, it tells SAS to match anything except A, B, and C. You see, it didn't match B or ABC. but it matched X, ABCX, because it includes an X. Backslash lowercase b matches a word boundary. For example, a space or beginning or end of a line. You can see it matched ABC, but not X, ABCX. Inside our brackets, we can also use a hyphen to represent through, as in matches any letter from V through Z. All strings that include a letter from V through Z are flagged. A number inside curly braces tells SAS to match the pattern before the curly braces at least the number of times indicated. In this example, we tell SAS to match 5 digits in a row. We see it matches a 6-digit number because it includes 5 digits. If we insert an I between the last backslash and single quote, it tells SAS to ignore case when matching. In this case, on the letter A. We match string with the lowercase a, but also strings with an uppercase A. Parens can be used to group patterns that can be separated with a pipe to indicate or. For example, here we're telling SAS to match on one pattern with 2 digits followed by an A, or Steve. We can see it matched strings Steve and 42A. So let's match a phone number pattern. Phone numbers start with an open paren. But remember that parens are special characters in regular expressions and are used for grouping a pattern like we saw in the previous example. But we can tell SAS to evaluate our open paren literally by using the escape character backslash like this. Inside our parens we need 3 digits followed by a closed paren. Again, we need to escape it, so SAS treats it as a literal closed paren. Next, we need 3 more digits followed by a hyphen. A hyphen is also a special character in regular expressions, so we need to escape it as well. Then we add 4 more digits. And when we run this, we see that it matched one of our phone numbers, but not the one down here. And that's because there's a space after this closed paren. Now we could add a backslash S after our closed paren, but then it wouldn't match our phone number without a space right here. To solve this, we add an asterisk after backslash S. The asterisk tells SAS to match on a white space character 0 or more times. So let's run this again. Now we see it matched both of our phone numbers. There are lots of websites that list the meta characters and show examples of different patterns. One is this SAS regular expression tip sheet, which groups them by category. For example, here we see the shorthand pattern values, and here we see the position matching values. I put this link and a couple of others in the description. And that's it for this video. Hopefully you learned how regular expressions can make you a more efficient and flexible programmer. Look for the next video in this series on finding a pattern and replacing the value. If you found this video useful, please give it a thumbs up and be sure to subscribe to get more content. Thanks for watching.